Buoyancy and stability. Buoyancy and stability are two key principles that keep a seagoing vessel afloat on water. Buoyancy is the upward force exerted by water that keeps a ship afloat. Stability determines a ship's ability to return to an upright position after being tilted by external forces such as high waves or strong winds. Buoyancy ensures that the ship floats, while stability ensures that it does not capsize or tilt sideways. This is ABHA, and this lesson explains key factors in buoyancy. Buoyancy. Why do ships stay afloat on water? Ships stay afloat on water because of a fascinating principle of physics called buoyancy. So, what is buoyancy? The principle of buoyancy was first explained by Archimedes, a brilliant ancient Greek scientist who lived more than 2000 years ago. He formulated the principle of buoyancy, which is now known as Archimedes' principle. This principle states that a body submerged in water will experience an upward force equal to the weight of the water displaced by it. Buoyancy is the upward force exerted by water that opposes the weight of an object submerged in it. This upward force exerted on an object in water is called buoyant force. If this buoyant force is greater than the object's weight, the object will float. This is why ships, despite being heavy, stay afloat due to their design and displacement of water. A ship's hull is designed to displace enough water to create a buoyant force that supports its weight, even when loaded with cargo. The buoyant force pushes upwards against the ship's hull, while gravity exerts a downward force on the hull of the ship. Hence, when the force exerted downward on the hull by gravity is less than the buoyant force, then the ship will float on water. When a ship floats, it displaces a certain volume of water. The weight of this displaced water creates an upward force known as buoyancy. For a ship to float, the buoyant force must equal the ship's weight. Ships designers carefully calculate the volume and shape of the hull to ensure it can generate sufficient buoyant force even with heavy cargo on board. When a ship is placed in water, its weight pushes the water downward. At the same time, the water pushes back up with an opposing force that is known as buoyant force. The key is for the ship to displace enough water so that the buoyant force equals the ship's weight. Ships are designed with hollow hulls, making them less dense than the water they float in. This lower density helps them stay afloat despite their heavy weight. Ships are enormous steel vessels weighing hundreds of thousands of tons. Steel is much denser than water. So what helps keep ships afloat is their shape and what is inside them. A ship is not a solid piece of steel. It has all sorts of components inside, such as the ship's engine, fuel, and cargo. Inside all these components, there is something very important. It is called air. The air that is inside a ship is much less dense than water. That's what keeps a ship floating. The average density of the total volume of the ship and everything inside of it, including the air, must be less than the same volume of water. As a ship is set in water, it pushes down and displaces an amount of water equal to its weight. The closer the total density of the ship is to the density of the same volume of water, the greater the amount of the ship that will be in the water, which in this case is the hull of the ship. If the average density of the ship is ever greater than the density of water, then the ship will sink in the water. When a ship sinks, it is because water enters the ship. This forces out the air, making the average density of the ship greater than that of the water. As more water enters the ship, the air is forced out and the ship loses its buoyancy. This causes the ship to sink, as without buoyancy, the ship cannot stay afloat.